Good evening, everybody. This is our sixth lesson for the year. So tonight I'm going to look at problems 1 to 5. And the next session, hopefully we will get to look at problems 6 to 10. So you are more than welcome. The link hasn't expired. You can submit your answers to questions 6 to 10 for the next lesson. All right. So let's start with problem 2. And so I got 12 submissions, 9 people got it right, and I hope they solved it without a calculator. All right. Now looking at this problem, this should remind you of the theorem that a minus b times a plus b is equal to a squared minus b squared. So that theorem. Now, looking at the exponents, are the exponents the same? This bracket has an exponent and that bracket has an exponent. Are those exponents the same? What do you guys think in the chat? Yes or no? Are the exponents the same? Richard, Zadwick, Takura? Are the exponents the same? Nope, they're not the same. But what we do remark is that 7/3 minus 1/3 is equal to 2, which is a whole number. So that's quite suspicious. That's quite suspicious. So the trick here is to rewrite the question as root 10 minus root 2 raised to the power of a third, root 10 plus root 2 raised to the power of a third times root 10 plus root 2 raised to the power 2. Alright, and so here you can see you have a minus b times a plus b. So this then becomes a squared, which is 10 minus b squared, 2 to the power of a third, root 10 plus root 2 squared. Can I get a yes that you guys agree with this maths? Can I get a yes that you guys agree with this maths? So no need for calculators. No need for calculators. The trick is to rewrite 7/3 as 2 plus a third. Alright, and now we're lucky. What's 10 minus 2 raised to the power of a third? 10 minus 2 raised to the power of a third? Yep, it's the cube root of 8, which is 2. And this we know is 10 plus twice this times this, which is root 20, plus 2 squared, which is 4. And so if you simplify this, the square root of 4 is 2. So this is 2. So 10 plus 2 is 12. 12 times 2 is 24. And we know that we can rewrite square root 20 as square root 5, square root 4. Square root 4 is 2. So this is 8 root 5. And so, is this correct? So this is 8 root 5. And so the answer is which letter? So the answer is which letter? I'm hearing crickets. Talk to me. Yes, C. So 12 people tried this problem and 9 got this right. 12 people tried this problem and 9 got this right. So you see, it's a very easy problem. All right. So if you haven't done this problem, redo this later today. All right. So the second problem that I want to look at is, first we're going to start with a theorem. So we're going to start with the following theorem. Say a is a non-zero number. You can show the sum of the roots of ax squared plus bx plus c is equal to 0 is minus b over a. And the product of the roots of ax squared plus bx plus c equal to 0 is c over a. So if you want to read more about this, you are more than welcome to read up on Vieta's formulae. But let's quickly prove part 1. So I'm going to prove part 1. So I'm going to prove part 1 by using what result? So how do we solve a quadratic equation? Can anybody tell me in the chat, or maybe unmute?
Quadratic formula.
Yes, good stuff. So thank you, Takura, as well. So using the quadratic formula, and I hope you guys have written up the quadratic formula. So the quadratic formula should be on a piece of paper stuck in your bedroom. So using the quadratic formula, the roots are, so the first root is going to be minus b minus the square root of b squared minus 4ac over 2a. And the other root is minus b plus the square root of b squared minus 4ac over 2a. Alright. Can I get smiley faces that you guys know this formula? So, if you have a quadratic equation, can I get one more smiley face? There you go. Alright. And now let's have a look at the sum of the roots. So if we add up the roots, we got to add the two fractions. And if we add up the two fractions, you can see that this disappears when you add it to that. So what you end up getting is minus 2b over 2a. You can knock off the 2's and you get minus b over a. So this is a very simple proof. Likewise, I'm going to leave this as homework. If you multiply the product of the roots, you will get this. So this is a wonderful result because you get to know the sum of the roots without knowing the roots, and the product of the roots without knowing the roots. And this works regardless whether the roots are real or complex. And so this is a really stunning theory. Alright, and so there's more about this. So we can do similar results for cubic polynomials, polynomials of degree 3, or if you want to, polynomials degree 4, 5, and 6. But the formulation is a little bit more complicated. Are there any questions or comments? So this is a very useful theorem, and there are Olympiad problems where this makes an appearance. Alright, can I get a yes? You guys have written down this theorem? Can I get a yes that you guys have written down this theorem? So if you look at a standard quadratic, the sum of the roots are minus b over a, and the product of the roots are c over a. This is not the only way to prove it. So this proof uses the quadratic formula, which every student doing maths should know. Alright, so let's see an Olympiad problem where that makes an appearance. So again, surprisingly, 12 students tried this problem and 9 got them right. So the root of this quadratic equation is m and n. And they tell us that m is not 0 and n is not 0. And you want to find a quadratic equation whose roots are m over n and n over m. Alright, so we're dealing here with two quadratics. So if we start with this quadratic, minus 7mx plus 5n is equal to 0. So who can tell me what the sum of the roots are? So what is the sum of the roots using the theorem? So using this theorem that I just mentioned, the sum of the roots is what? So applying this theorem, who can tell me? Directly applying the theorem, what are the sum of the roots? Alright, remember Takura, the formula is minus b over a. Takura, can I get a yes? That the formula is minus b over a. Takura? Luke, can I get a yes? The formula is minus b over a. Takura, can I get a yes from you? Okay, and so in this question, Takura, what is a? Takura or Luke, what is a? Takura, what is a? What is the value of a? A is the coefficient of x squared is 1. B is the coefficient of x. What's the coefficient of x, guys and girls? Guys and girls? B is? Anybody? Tell me what B is? Yep, minus 7m and C is 5n. Can I get smiley faces? In this quadratic, A is the coefficient of x squared, B is the coefficient of x, and C is the constant. Alright, so if we apply to this problem, it's minus 7m over A, and so the sum of the roots is 7m. And just for fun, the product of the roots is c over a, which is 5n over 1, which is 5n. Alright. But we know the roots are m and n. So we know that m times n, that's equal to 5n. And because n is not 0, we know that the value of m is 5. So we know that the value of m is 5. Alright. Likewise, we also know that m and n are the roots, so m plus n is equal to 7m. And we know that m is equal to 5, so 5 plus n is equal to 7 times 5. So what's the value of n? Can anybody quickly tell me? What's the value of n? Yep, it's 30. Alright, and so now we want a quadratic with roots m over n and n over m. So the sum will be m over n plus n over m. So m is 5, so it's 5 over 30 plus 30 over 5. And who can tell me what that simplifies to? So using the information, we see m must be 5, n must be 30. So 5 over 30 plus 30 over 5 simplifies to what fraction? Anybody? Can we get confirmation with Majosi and Chatterjee? Can we get a third Do you guys agree? Thank you, Caroline. Thank you, Caroline. Yeah, it's 37 over 6. And we know that the product will be m over n times n over n, which is equal to 1. So we see that what we can have is the following. I think I'm gonna do this way. All right, this is fine. This is fine. You guys can see the answer already popping up, but we can also see that m over n is equal to 5 over 30, which is 1 over 6, and n over m, n is 30, m is 5, which is 6. So x minus 6 times x minus 1 over 6 equal to 0 has the properties. Can I get smiley faces that you guys see that the quadratic x minus 6 times x minus 1 over 6 equal to 0 has m over n as a root and n over m as a root. There are many ways to solve this question. Alright, but using the theory that we know the sum of the roots and the product of the roots and playing with other information, we get this. Can I get one more smiley face? Can I get one more smiley face that you guys follow the maths? If you have a question, alright. Now, if we multiply this out, we get x squared minus 37 over 6x plus 1 equal to 0. But it's not on the list. Alright, but we can modify it and it becomes which one on the list? So who can tell me which one on the list does it become? Yep, it becomes D. So if we take this equation and we times by 6, we get D. Alright, any questions or comments? Any questions or comments? Are you guys happy? Can somebody unmute and say they're happy? I want to hear a voice.
Yes, Dr. Wiggins. I'm happy.
Thank you. It's good to hear your voices. Alrighty. Now let's get to the toughest problem. This is why I want you guys to do the problems so that I can see what is the toughest problem. So 12 people tried this. Only 5 got this right. So here you have big numbers and you need to order them. So you have massive numbers and you need to order them. Alright, now are you going to multiply 4 with itself 3,000 times? What do you guys think? You're in an Olympiad, no calculators, lots of problems to solve. Nope, you are not going to do this. Alright, so this is how I would start the problem. Looking at the exponents, we have 3,000, we have 2,500, and we have 2,000. What is the GCD? So starting with the exponents, we have three massive numbers. What is the GCD? Remember the greatest common divisor. We've talked about the GCD in previous lessons. You can tell me in the chat. You can unmute your microphone. What is the GCD? Luke is giving me a number. Can I get another number? So the greatest number that divides all of them. Alright, so Luke, no need for a question mark. Majosi, no need for a question mark. It is obviously 500. It is obviously 500. So what I'm going to do is I'm going to divide each exponent by 500. So this is going to become 4 to the power 6. This is going to become 6 to the power 5. And this is going to become 7 to the power 4. Alright? So no need to deal with big numbers. We take each exponent and we divide it by 500. So if we can order these numbers, then we can order those numbers. Alright. Now, this one we can quickly do. 4 is 2 to what power? 4 is 2 to what power? Yep, it's 2 squared. So this is 2 to the power 12. And we can write this as 2 to the 10 times 2 squared. And you should all know what 2 to the power 10 is. What's 2 to the power 10? 2 to the power 10? Takura, it's 1024. So you see 124. So if you multiply it by 4, it's quite clear that this is 4096. Alrighty. So 7 to the power 4 is 7 to the power 3 times 7 to the power 1. What's 7 to the power 3? Anybody? Yep, it's palindrome. It's 343 times 7. I'm sure you guys can do that calculation. So this is 2401. Now 6 to the power 5, we can write this as 6 squared times 6 cubed, which is 36 times 216. Alright, how do we multiply numbers without a calculator? You are stuck on an island. Maybe your calculator broke. How do we multiply numbers? Anybody? Yes, lattice multiplication. Thank you, Zerwig. So we talked about this last time. So let's apply this to this question. Alright, so we have 36 over there. We have 216 over here. So we do some lattice multiplication. That's heaps of fun. 3 times 2 is 6, 3 times 1 is 3, 3 times 6 is 18, 6 times 2 is 12, 6 times 1 is 6, 3 times 6 is 6, and then you add up like this. So you have a 6 here, and then here you have 8 plus 3 is 11, plus 6 is 7, carry a 1, 1 plus 1 plus 3 plus 2, that's a 7, and then 6 plus 1 is a 7. Alright, so looking at this, this guy is the biggest, so therefore B is the biggest. So B is the biggest. And then the next smallest number is this guy. So A is the next number, and the smallest guy is this guy, so it's C. So which option is corresponding to this order? Who can tell me? Which order is corresponding to this one? Yep. Good stuff. So the answer to this problem is D. Are there any questions or comments? So you can prove that 6 to the power 5 is more than 4 to the power 6, which is more than 7 to the power 4. And then if you raise this to the power 500, raise this to the power 500, and you raise this to the power 500, you get that the answer is D. Alright? Alright, I can quickly do that. Are there any more questions or comments? Any more questions or comments? So, obviously this is an Olympiad problem, and you're not supposed to work out 4 to the power 3000 or 6 to the power 2500. or 7 to the power 2000. So you're supposed to find quick ways to order these numbers. So looking at the GCD, we can divide each exponent by 500, and these are things that you can do by hand. Are you guys happy? Can I get smiley faces? So the reason by dividing by the GCD is so that we're dealing with smaller numbers. So to order A, B, and C is equivalent to order D, E, and F. All right? Takura, are you with me? If we can order D, E, and F, then by raising that to the power 500, we get to order A, B, and C, because all of these numbers are positive. All right? And remember, you need to find clever ways to order this. All right? So these numbers are massive, but we want to know which is the biggest. It turns out to be B. Which is the second biggest? It turns out to be A. And which is the smallest? It turns out to be C. All right? And we don't have supercomputers to help us with all of the math. So we need to find ways of finding equivalent problems that's easier to do by hand. All right? So by dividing by the GCD, we get to deal with smaller numbers which we can easily order. All right? Any questions or comments on this example? All right? Are you guys happy? I hope you have pen and paper and taking notes. Are there any questions? Guys, if you have a question, you can quickly unmute. So you can clearly see this is an Olympiad problem. And you can make many problems similar to this. Alrighty, there doesn't seem to be any questions. Alright, so this is all good. Alright, so as a reminder, tonight we are only looking at problems 1 to 5, and in the next session we're going to look at problems 6 to 10. So if you have time in the next coming week, try problems 6 to 10 and submit them. Alright, I would like to know how it is going. But surprisingly, 12 people tried this question and only 5 got them right. Alright, so the next problem, 12 people tried this problem and again 9 got it right. It seems 9 was the magic number here. Alright, so if log base 21, 3 is x, we want to express log base 7, 9 in terms of x. Alright, so those of you in grade 10, let me quickly remind you of the definition. So log base x of z is equal to y if x to the power y is equal to z. So we're basically asking ourselves, to what power should we raise x to give me z? So let's just quickly do a couple of examples just to see that you guys are happy with this definition. So what is log base 2 of 8? So what's log base 2 of 8? Yep, good stuff. So in maths, it's important that you know what the notation means. So we're asking ourselves, 2 raised to what power will give me 3? I want to do another fun one. Alright, so I want to do this one. So who can tell me log 8 and I have a half here? What is this guy? So 8 must be raised to what power to give me a half? Majosi, you're pretty smart. Can I get smiley faces that you guys agree with that? Since 2 to the power 3 is equal to 8. Yep. This is equal to minus 3. Since, let me write it down. Since the base to the power minus 3 is equal to a half. Let's just do one more. Alright. let's just do one more to see. Let's do this one. Who can tell me what this is? Oh, sorry. Yes. This should be minus a third, because 8 to the power minus a third is 1 over 8 to the third, which is 1 over the cube root of 8, which is equal to a half. Alright, so can I get somebody to say they agree that this answer is minus a third? Yeah? But Josie, thank you, Zervik, for picking that up. Guys, you need to double check. You need to triple check. This applies to second year students as well. All right. So, what do you guys think this answer is? So, do you guys agree with Chatterjee, Majosi, Zervik? Thank you, Caroline. Thank you, Majosi. All right. So, this is 7 over 2. All right. There's many ways you can work this out. Maybe one way you could have said is this. Say this guy is equal to a. So that means that 4 to the power a is equal to 128. 128 is 2 to what power? 128 is 2 to what power? Yep, 2 to the power 7. And we know that this is 2 squared, so this is 2 to the power 2a. So if this guy is equal to this guy, the exponents have to agree, so a has got to be 7 over 2. Can I get smiley faces that you guys are happy with this maths? So you don't need calculators to determine 4 to what power should be 128. So if you do the maths carefully, you get the answer should be 7 over 2. Can I get one more smiley face? Alright, so log is just asking, to what power should I raise the base to give me z? Can I get one more smiley face? I'm sure there's a lot of people here. Thank you, Luke. Thank you, Jared. I'm looking for one more smiley face that you guys agree with this. Can I get one more smiley face? Thank you, Takura, Kwacha, and Zerwik. Alright, so now let's tackle this problem. So let's tackle this problem and see how do we solve this. Alright, so we know that log 21, base 21/3 is x. So who can tell me what information do we get from this equation? So rewriting this without log, what information do we get from this? What to what power is equal to what? So apply the definition. Do you guys agree with Takura? So 21 to the power x is equal to 3. Can I get... Thank you, Majosi. Yeah, thank you. Great. All right. So now we don't have a calculator. All right. And we now need to work out this. So what was our very first lesson of the year about? It's a very cool word, starting and ending on the same letter. Thank you, algebra. So this is the solution. So from log 21 3 is equal to x, we get that 21 to the power x is equal to 3. And so now I'm going to do the following. Let log of 7/9 equal to y. So 7 to the power y is equal to 9. Can I get smiley faces that you guys agree? So I am introducing a second variable. Thank you, Majosi. Yeah, great. So applying the definitions, I have lots of variables. So I introduce a y. Tamron, do you want to unmute?
Sorry, can you just quickly scroll up so I can see the question, because that's why. Okay, so I just wanted to make sure, because why did you introduce the y in that way? But I see it's part of the question.
So the question is this monster. So we got to get this monster in terms of x. So this is why I'm calling this monster y, so that I can play with it in a nicer way. Are you happy with that?
Yes, thank you.
Pleasure. Alright, so guys, I really don't mind you interrupting, and that is a really good question. Alright, because if you don't have a calculator, how would you attack this question? Alright, so in this question, we need to play with log by 7 of 9. And so we don't have a calculator, so let's call this new guy y. Alright, if you have dogs and cats, you give them names. So this guy, we call it y. Alright, so now we have all of this. Alright, and so now comes the bit where we gotta have some fun. Alright, now we are quite happy that 9 can be written as what? How do we prime factorize 9? Yep, thank you, Majosi. It's 3 squared. Alright, so now let's have a look at this. Looking at 21 to the power x, wouldn't it be nice if we can have a 21 on the left? So let's do the following crazy thing. So I'm going to multiply with 3 to the y on the left, 7, and then I'm going to have 3 to the y times 3 squared. Can I get smiley faces for now that you guys see this crazy plan? So we know that 7 to the y is 9. So 7 to the y is 3 squared, and I'm multiplying with 3 to the y on both sides. And so by doing that, I now end up getting that 21 to the y is equal to 3 to the power y plus 2. Can I get a yes that you guys agree with this plan? Thank you, Kwacha. Can I get another yes? Yeah? Okay. So now, being inspired again by the block, I'm going to do the following. I am going to raise this to the power of x, and I'm going to raise this to the power of x. Alright, there might be other ways of solving this question, but I am raising both sides to the power of x. So now I have that 21 to the power x is equal to y, and here I have 3 to the power y plus 2 x. Alright, but now we know that 21 to the power x is equal to 3. So this now becomes 3 to the power y is equal to 3 to the power y plus 2 times x. Can I get smiley faces that you guys see how I turn 7 to the y is equal to 9 to 7 to the y is 3 squared. I multiply both sides with 3 to the y, so I get 21 to the y. Then I raise both sides. What you do to the left, you must do to the right. That is just the rules of algebra. What you do to the left, you must do to the right. And then I rewrite the left side and the right hand side, and then I get 21 to the x popping out. So I get that 3 to the y is equal to 3 to the y plus 2 times x. Alright, and so now we know that the exponents agree. So the exponents agree. So y should equal to y plus 2 times x. And which variable do we solve? Who can tell me in the chat which variable do we solve for? Thank you, Majosi. Thank you, Chatterjee. Yes. So remember, we are looking for y. We are looking for y. So we multiply out, so we get yx plus 2x. I'm doing this in baby steps, like you would explain to your friends at school. So we are solving for y, so we're doing this. And so we have y minus y, x is equal to 2x. We can take out y as a common factor, so we get y times 1 minus x is 2x, and so we get y is 2x over 1 minus x. So the answer to this multiple choice question is B. So this is maybe not the only way to solve it, but if you don't have a calculator, this is how you can do it. There's alternatives. So 9 people got this right. If you got this right and you did it in another way, do you want to share how you solved it?
Yes, I'd like to share if you got time. So
Yep, we have time. So,
Okay. Yeah, so I just used a lot of log rules because I was a bit lazy to go to the exponents. So what I firstly did, I was trying that. I firstly wrote log 7(9) and tried to get that as close as I can to log base 21 free.
mm-hmm.
So we have the log rule that you can use to substitute the base. I think I'm using the right terminology. I don't know.
Are you saying you change this into log 9 over log 7?
Yes, but the base 21.
Oh, okay, and then you modify this to base. Yeah, this is true for any base. Yeah.
So the top one simplifies to log base 21 3 to the power of 2, which just turns out to be 2x of log rules.
Oh, okay. Let's bear with me. Yeah. Let me just create a new page. Insert new page. So there's also log laws. So what I did was I did this from definition. So nothing fancy. So, but what he's proposing. So don't unmute your microphone. Stay online.
Just to minimize the noise.
Noise. But I don't think it's that hectic. So this is a log law. You guys can look it up. And then the 9 can be written as 3 squared. And so you end up getting this. And there's a log law that says, let me write down that log law, that log a to the power b is b log a. So this becomes twice log 21(3) over log 21(7). And so we know that this guy is x, so this is 2x over. And how did you deal with the bottom?
Yes, so that one I actually had to go back to just the statement, the expression that tells us what x is.
Okay, but let me help you out. Okay. So who you guys can tell me what's log 20, what's this guy equal to? Do you guys agree with Chatterjee and Majosi? Can I get one more confirmation? What's log base 21 of 21? Thank you, Luke. Do you agree that it's 1 because 21 raised to the power 1 is 21? Hi, are you there?
Oh yes.
All right. And so now we know that 3 times 7 is 21, right?
Yes, that's exactly what I did.
So we know from this log law that this must equal to this. But we know that this guy is 1. And we know that this guy is called x. And so we can see that this guy is 1 minus x. So you can see, and this is an alternative solution.
Yes. I just realized it when I played around with the first one a bit, but that's exactly what I did as well.
Thank you for sharing.
It's kind of neat how that works. You can derive it from just the identity of 21 to 1.
Correct. So guys,
thank you, sir, for giving me a chance to share.
It's a pleasure. Thank you for sharing. All right. Mr. Priya, you have a question?
You can call me Cameron,
yeah. Okay.
But I think you put it in wrong. It should be the log 21(3) that becomes x, not the log 21(7).
Oh yeah. So I flipped them around. Thank you, Tamron. So remember this is called x, and then you get this, and so we can see that the blue term is 1 minus x, and so the blue term is 1 minus x. Guys, can I get smiley faces? So this is a nice thing about maths questions, that sometimes there are many ways of solving them. All right? There are many ways of solving them. So the way that I'm showing might not be the only way to solve it. All right? So maybe you found a nicer way, a more elegant way of solving the question. All right? So do take note that I'm just giving you a way of solving it, but it may not be the only way to solve it. And this is what's nice about Olympiad problems, that there could be several beautiful solutions out there. So the first solution just uses the definition and basic properties of exponents. This solution uses some log law. So if you've been playing a lot with logs, you can also stumble across this solution. All right. Any questions or comments on this problem? So again, thank you for sharing your solution. Clearly, my brain was working in a very different direction, but there are other nicer solutions to this problem. So yeah, this is the beautiful thing about maths problems. You can solve them in very nice ways. Alrighty. So, time is flying. So let's look at the very last problem. And surprisingly, 12 people tried this problem and 9 got them right. So it seems to be 9 is the magic number. Alright. Now for this problem, it's a little bit tricky if you haven't done a lot of trigonometry. Alright. This one is a little bit tricky if you haven't done a lot of trigonometry. Alright. So to solve this question, you are going to need this theorem, that cos x plus y is equal to cos x cos y minus sin x sin y. So if you're in grade 10 and you haven't done a lot of trigonometry, don't worry about this. Most South African Olympiad problems don't have a lot of trigonometry in them. But especially in American Olympiads, and I think I got this problem from a Singapore Maths Olympiad, they expect their students in grade 10 to know a lot of trigonometry. Alright, so I would advise you, write down all the trig identities on a piece of paper and stuck it in your bedroom. Alright, I think some of you guys probably have Marvel DC cartoons stuck on your bedroom walls. Or what do you guys stuck in your bedroom walls? Posters? Nothing? Can I get some ideas what you guys stuck in your bedroom? So there are compound formulas for cosine and tan. So Luke is doing maths equations. You're making my heart warm and fuzzy. Majorzi's got posters of planets. A wall mural. Alright, so yeah, it is sometimes good to the periodic table. Oh, that's awesome. I remember reading Tintin when I was a youngster. Yes. Alright, so you got to solve this problem with this identity. Alright, without this identity, you're stuck. General science posters. That's also awesome. Edward, that is also awesome. Alright, so to solve this problem, you're going to need this identity. Alright, so now we are told that sine x is 12 over 13. So what you're going to do is draw a little triangle. Alright, what is the definition of sine x? Yoda. Somebody is a big fan of Star Wars. Alright, and science and maths. Alright, so anybody in grade 10? If you're in grade 10, what definition did your teacher tell you what sine x is? So if you're in grade 10, what definition did your teacher tell you what sine x is? Man of culture, I see. Alright, so grade 10 and 11s, what's the definition for sine x? So let's call this angle x. What's the definition for sine x? Opposite over adjacent. Alright, nope. It's opposite over the hypotenuse. Alright, but the problem is, so in this case it's 12 over 13. So if that's 12, that's 13. What is this distance? Guys, what is this distance? From there to there? So 5 using Pythagoras, right, Majosi? 5 using Pythagoras, right, Majosi? Yep, alright. So we can see that sine x is 12 over 13. And what is cos x? Who can tell me what cos x is? Cos x is what value? I am not. Yep. Cos is adjacent over hypotenuse. So it's 5 over 13. Alright. But there's a problem with this definition. There's a problem. What is the problem with this definition? If you say sine is opposite over hypotenuse and cos is adjacent over hypotenuse, what is the problem with that definition? Who can tell me? Majosi, I'm looking for something a little bit more deeper. I'm looking for a little bit more deeper than that. All right, so you're quite right. With that definition, you only get positive values. All right, but what is the definition by saying form a right angle triangle, pick an angle that's one of the coming from the two smaller sides, and then you say sine is opposite over hypotenuse and cos is adjacent over hypotenuse. Anybody grade 10, 11 or 12 can tell me what is the problem with that definition? All right, there's a problem with that definition. Anybody? Have I stumped you guys? Matrix? You should have thought about this. Anybody? So I would say one of the problems is this only works if the angles is between 0 and 90 degrees. All right? And so you have an issue. What about, let's say, sine 200 degrees? Because you know that the angles in a triangle adds up to 200. Or if you want to know what is sine 21 degrees. Can I get a yes that you guys see? The problem with this definition is you can't construct a triangle where one angle is 90 degrees, one angle is 200 degrees, and the other angle is not negative. So this definition only works in the first quadrant, and this is what somebody was alluding to. This definition only works in the first quadrant. All right? So remember, we want to take sine of any angle, big or negative. All right? Big positive or big negative. All right? So we need a better definition. So if you look at the following, what we can do is we can measure an angle theta, and we can take this point with coordinates x, y. So let's call that O, let's call that P, let's call that 90 degrees. And so the distance from there to there is x, the distance from there to there is y, and that is r. So if you now look at something like sine of the angle, we would like to define this as opposite over hypotenuse. But in this diagram, what is the value opposite angle theta? Who can tell me what is the value opposite to angle theta, the length of the side? Yep, it's y. And the distance from O to P is r, so we get y over r. Can you guys see that this definition, sine is defined as y over r, is better? Can I get smiley faces that you guys see that this definition is way better? All right, this is way better because now, for example, if you do 200 degrees, then what you do is you take a ruler and compass and you do something like this. So this would be 180 degrees, this would be 20 degrees, and you get a point P over here. So you get a point P over there. All right, so if you do this on graph paper, you can work out the x value and you can work out the y value. So if you're doing 200 degrees, is the x value positive or negative? So if you do 200 degrees and you draw this line where this angle is 200, yeah, x is negative and you see y is negative. Now the distance from O to P is always positive, all right? So now you can see that if you do sine theta, which is the y value of the point over r, is this quantity going to be positive or negative? So y over r, positive or negative? Can somebody unmute?
It'll be negative.
Yeah, it'll be negative. Why? Because y is negative because we're in the third quadrant, and r is always positive because r is the distance from the point to the origin. All right, so this is a way better definition, and this works in all quadrants. This works in all quadrants. And who can tell me what's the definition for cos? What should the definition for cos be? Can somebody unmute and tell me what should the definition for cos be? Yeah.
3 people have said x over r.
Okay, x over r. Okay, load shedding just started my side, so I don't have my second screen, Tamarin. This is what's going on. All right, and so tan is going to be the opposite, which is y, over the adjacent, which is x. Can somebody unmute and see that these definitions, you draw an angle theta starting anti-clockwise from the x-axis. So if theta is positive, it's anti-clockwise. If theta is negative, you would go clockwise. And if you form a point P, whatever quadrant with coordinates x, y, and the distance from point P to the origin as r, so then sine is then defined as y over r, cos is x over r, and tan is y over x. So in the first quadrant, this turns into the definition that you learn, but this works in all quadrants. If you have a working microphone, can you unmute and tell me that you're happy with this definition? Because it works in all quadrants.
I agree. I'm happy with the definition.
Thank you. Thank you. So you can see some definitions are okay, but the problem with defining sine as opposite over hypotenuse, it only works in the first quadrant. So you need a better definition. So this definition works in all quadrants. And why do I go on about this? Because look at this, what we have over here. They also tell us that cos y is minus 4 over 5, and y is sitting in which quadrant? Who can tell me? Y is between 90 and 180 degrees. So which quadrant is y sitting? If somebody has a microphone, please unmute. Which one?
In the second quadrant.
Yes, it's in the second quadrant. So if your angles are between 0 and 90 degrees, it's in the first quadrant. If it's between 90 and 180 degrees, it's sitting in the second quadrant. If it's between 180 and 270, it's sitting in the third quadrant. If it's between 270 and 360, it's sitting in the fourth quadrant. So it's always good to draw the quadrants. It's always good to know where you are dealing. So x is between 0 and 90, so it's sitting in the first quadrant, and we've done the maths. Y is sitting in the second quadrant. All right, so for this question, you need to know trig well. So you need this identity, which I want you guys all to write down, put on a piece of paper, stuck it in your bedroom. All right, and you also need to know the correct definition. So we are going to use the correct definition. So remember, we want cos to be minus 4 over 5. So what you do is, so we want cos of the angle to be minus 4 over 5. So let's do the effort of drawing our little diagram. So we have something in the second quadrant. And so this angle, let's call it now, okay, they actually should have called this a different letter, but it's okay. So for now, I'm just going to call this theta. So I'm going to call this angle theta. And so we know that the coordinates of this point P is x, y, and this distance is r. So we know from the definition that cos is x over r. So it's x over r. And we know we're in the second quadrant. So in the second quadrant, here, x is negative. So you can see it comes to your advantage to write this fraction as minus 4 over 5. So you can see r let's make r 5. So if r is equal to 5, then x has got to be minus 4. And then we know that x squared plus y squared is equal to r squared. That's Pythagoras. And because we're in the second quadrant, we know that y is positive. So who can tell me if r is 5, x is minus 4, and x squared plus y squared is equal to r squared, and y is positive, what should y be?
3, Dr. Wiggins.
Good stuff. Y should be 3. All right, this is why it's important to draw. It is important to know that you are dealing with a point in the second quadrant, because in the second quadrant, x is negative, but y is positive. And so why is this good news? Because now we know that sine of the angle is y over r. We just worked out that y is 3 and r is 5. So this is 3 over 5. All right, and so now we can go back to the question, and now we can fill in the stuff. So cos of x, from this first diagram, we know that cos of x is 5 over 30. And we know that cos of y is minus 4 over 5, because that's given. And we know that sine x is 12 over 30. And then sine y is this diagram over here. Sine y is 3 over 5. So it's 3 over 5. So you get minus 20. Minus 20 minus 36, which is minus 56 over 65. So the answer to this question is A. So the answer to this question is A. And that is my story for tonight. I hope